Hello students. So let's solve miscellaneous exercise. First question is, how many words with or without meaning, each of two vowels and three consonants, can be formed from the letters of the word daughter? Okay. So the word which is given is daughter. So how many vowels are there? E. Three vowels and 1, 2, 3, 4, 5. 5 consonants. So total 8 words, 8 letters are there, right? So we have to form a word of 2 vowels. So out of 3 we have to choose 2. So 3C2, and out of 5 we have to choose 3. So 5C3. Okay. Now this is with or without meaning. So this 5 letter word can be arranged in 5 factorial ways. So into 5 factorial. Okay. So this is 3 factorial upon 2 factorial, 3 minus 2, 1 factorial into 5 factorial upon 3 factorial into 2 factorial into 5 factorial. Okay. So 3 factorial is 3 into 2 factorial. 5 factorial is 5 into 4 into 3 factorial. 3 into 10 into 5 factorial. 5 into 4 into 3 into 2 into 1. So it's 600. Okay. Second question. How many words with or without meaning can be formed using all the letters of the word equation at a time so the vowels and consonants occur together? Okay. So equation. Vowels are 1, 2, 3, 4. Consonants is 1, A, E, I, O, E. Consonants 5 are there. So 3 consonants. So we have to take all the vowels and consonants occur together. Okay. So this 5 vowels and consonants are Q, T, N. Okay. If they occur together, then only 2 letters are possible. Right. So the number of words will be what? Here no choosing of the letters and all. Okay. So 2 factorial, that is permutation, 2p2. Okay. How many letters are there in this 5? How many letters are there in this? 3. So this can be arranged in 5 factorial ways. Means if this is one arrangement, then another arrangement, then another arrangement. So this is our total way the 2 letters are arranged. But in this, that is inside of this, we have to arrange the vowels also in 5 factorial ways. And here consonants also in 3 factorial ways. So total it will be using the multiplication principle. 2 factorial into 5 factorial and into 3 factorial. Okay. So you have to take the factorial and multiply. So the answer is around 1440. Third question. A committee of 7 has to be formed from 9 boys and 4 girls. How many ways can this be done when the committee consists of exactly 3 girls, at least 3 girls, at the most 3 girls? Okay. So committee of 7 has to be formed from 9 boys and 4 girls. Okay, 7 people you have to choose. So first one they have given exactly 3 girls. So if you are choosing exactly 3 girls out of 4, then it is 4C3 and the remaining are boys. Total 7. So 4 boys you have to choose from 9 girls, 9 boys. Okay. So then you can do this 4 factorial upon 3 factorial into 1 factorial upon 4 factorial into 5 factorial. So 4 into 3, 9 into 8 into 7 into 6 into 5 factorial. So 4 you can write it as 4 into 3 into 2. Then you have to multiply and get around 504. Okay. Next thing which is given is 1 boy and 4 girls. At least 3 girls. So more than 3 can be taken. So start with 3. So first possible combination is 3 girls and 4 boys. Then plus 4 girls and 3 boys. Okay. So this is out of 4 you are choosing 3. Out of 9 you are choosing 4. 4C4. 9C3. Correct. Total answer is 5. Okay. Next one. At most 3 girls. So the maximum number of girls you can allow is 3. So start with 1. Okay. So 1 girl and total 7. So 6 boys. Then 2 girls and 5 boys. 3 girls and 4 boys. Yeah, at most 3. Okay. One more possibility is also there. That is total boys are 9. So we can choose all the boys. And 7, total 7 boys and no girl. Okay. So 0 girl and 7 boys. Okay. So this is 4C1, 9C6, 4C2, 9C5, 4C3, 9C4, 4C0, 9C7. Okay. Answer is 168. Next question is, if the different permutations of all the letters of the word examination are listed as in a dictionary, how many words are there in this list before the first word starting with E? So here we have to make use of the knowledge of that dictionary words. Okay. So examination. How many are repeated? A is repeated 2 times. I is repeated 2 times. N is repeated 2 times. Okay. So we have to find how many words are there in this list before the first word starting with E. So first word starts with A, correct? So if I fix A here, okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 words are there, 10 letters are there. So 10 factorial upon how many are repeated? A is not repeated now because one A is fixed and another A is here. So I is repeated 2 times, N is repeated 2 times. So this factorial we have to find. So it comes around 907200. Okay. Next word, the next letter is E. So before that, this many words are there. And this is the answer. Okay. Next question. How many 6-digit numbers can be formed from the digits 0, 1, 3, 5, 7, 9? Okay, which are divisible by 10 and no digit is repeated. So divisible by 10 means 0 we have to fix at the unit place. Okay, so these numbers can be rearranged here. 1, 2, 3, 4, 5. 6-digit number. Okay, so how many are there? 5. So 5, 3, 5, 5 factorial. That is 120. Okay. Next question. The English alphabet has 5 vowels and 21 consonants. How many words with 2 different vowels and 2 different consonants can be formed from the alphabet? So how many vowels? 5 vowels and 21 consonants. So we have to choose 2 vowels. So 5, say 2, and 21 consonants. 2 different consonants also. 21, say 2. Correct? Total is into this. Okay. But now this is how many letters are there? 2 total letters in that word is 4. Correct? They are not given with or without meaning, but still we have to multiply by 4 factorial because this can be rearranged. So we have to make use of multiplication principle. So this is our choice of vowels. This is our choice of consonants. And then this letters are rearranged. So it is permutation. That is 4p4. Right? So 4 factorial. So total it comes to 50400. Okay. Next question. In an examination, a question paper consists of 12 questions. They divided into 2 parts, part 1 and part 2, containing 5 and 7 questions. A student is required to attempt 8 questions in all. So we have to choose 8 questions out of this, selecting at least 3 from each part. So 3 we have to select from each part, at least. So 3 or more than 3. In how many ways can a student select the question? Okay. So 3 or more than 3. Total 8. Correct? So if I select 3 here, then I have to select 5 from this. Then increasing this, that is 5C4, 7C4. Okay. Next one is 5C5 and 7C3. These are the possible combinations, and then we have to add this all three. So it comes to around 420. Okay. Next question. Determine the number of 5-card combinations out of 52 if each selection of 5 card has exactly one king. So how many kings are there? 4 kings are there. Out of which we have to select only one king. So remaining cards are 52 minus 4, that is 48. Out of which we have to select the remaining cards. Total 5 cards you have to select. So one card is already selected, that is king. Remaining we have to select from 48 cards 4. Okay, this is the possible way. So we can calculate this. This will be a very big number. Okay. So it is required to sit 5 men and 4 women in a row so that the women occupy the even places. How many such arrangements are possible? Okay. So even places means first place, second, third, fourth, fifth, sixth. So here man, then woman, then man, then woman, man, woman. So 3, 1, 2, 3, woman. 4 woman, 5 men, 1, 2, 3, 4, 5. Here again men. 1, 2, 3, 4, 5. 1, 2, 3, 4. Okay. So man can be seated in 5 factorial ways and woman can be seated in 4 factorial ways. Okay. It is around 2880. Next question. From a class of 25 students, 10 are to be chosen for an excursion party. There are 3 students who decide that either all of them will join or none of them will join. In how many ways can the excursion party be chosen? So here or is given, means we have to use plus. Okay, that is all are joining or none of them are joining. Okay, if 3 students, so 10 are to be chosen. Okay. All are joining means 25 students are there. From those, 3 have already joined. So remaining are 22, out of which we have to choose. Total should be 10. So 3 have already gone for the party. So they have joined. So 10 minus 3 is 7. So 7 we have to choose from 22 students. And here these 3 are not joining. So only 22 are there, out of which we have to choose all 10 because none of those students are joining. So this is the number of ways. Next question. In how many ways can the letters of the word assassination be arranged that all the S are together? Okay. So how many A? 1, 2, 3, 4, I, N. Okay. So all S are together. S are 4. So 4 S are together. Okay. How many letters are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 letters are there, out of which all S are together. So 13 minus 4, 9. 9 letters are remaining. Okay. And this I'm considering as one letter. So together with this, it will be 9. 9, remaining 9 letters. And this one. So total is 10. So 10 factorial upon, how many are repeating? 3, then 2, and this 2. Correct? And this also we have to take, that is rearranging this. So it will be 4 factorial upon 4 factorial. So this comes to 1. Okay, so no need to take that. So we have to calculate this, and this comes around 151200.